Good morning, students. This lesson is of class 10th for the subject of physics. Topic: zero work done, power and energy, which is covered in chapter 2, work, energy and power of your physics textbook titled Concise Physics by Selena Publications. This lesson is being submitted to you on 24th May 2021. So children, last week we have studied positive and negative work done. And today we will do one more category of work done, which is known as zero work done. Now children, the amount of work done by a force is zero in the following two conditions. Firstly, when there is no displacement, even when force is applied. What is the first condition? When there is no displacement. So children, suppose you are applying force, but there is no displacement. That is, S is 0. And in the formula W is equal to Fs cos theta, if I put S as 0, then what will happen? Yes, our work done will also come 0 because something multiplied by 0 gives us result as 0. So when there is no displacement, even when we are applying force, is a case of 0 work done. Now children can take a break, and in the meantime try to move a wall by applying force on it. What do you observe? Are you able to move the wall even if you apply more force? Children, take the help of your parents also and try to move the wall. Now you are applying much force, but are you able to move the wall? The answer is no. So in this case, even you are applying force, but work done by you, work done by your force is 0. I hope this is clear. Now coming to the second condition, which is very important condition, when the displacement is normal to the direction of force. That means when the angle between displacement and applied force is 90 degree. Normal means perpendicular, which further means angle is 90 degree. Children, cos 90 is 0. You must have done in mathematics. Cos 90 is 0. Now let us see an example under this category. Children, when a body moves in a circular path in a horizontal plane, we did in first chapter that when the body is moving in a circular path, there is a special force acting on it, which is directly towards radius but an inward direction. So children, what happens when a body moves in a circular path? Then centripetal force on the body at any time, at any instant, is directed towards the center of circular path, and the displacement at that instant is along the tangent. The velocity was also along the tangent. Displacement is also along the direction of velocity. So displacement is acting tangentially while force is acting along the radius towards the center. Now children, this is a property of a circle that radius is always perpendicular to tangent. Radius and tangent are perpendicular to each other. So you can see that angle between force and displacement is 90 degree. So that means that when a body moves in a circular path, then work done will be always zero. Why? Because displacement is acting tangentially while force is acting towards the center along the radius. Thus, the angle between force and displacement is 90 degree, and when we use the formula work done is equal to Fs cos theta, we'll write down theta as 90 degree and cos 90 is 0. So therefore, work done will come out to be 0. So children, there is one more example I want to share with you all. When a coolie picks a suitcase and walks on the road, then work done against the force of gravity will be 0. Which work done is 0? Work done against the force of gravity. Now this happens because the weight of suitcase is acting downward. Children, weight always act downward. We did in first chapter also. So weight of the suitcase is acting towards the earth. It is acting along downward, in downward direction. While suppose coolie is moving towards right direction. So the displacement is towards positive x-axis, right direction. Now children, kindly see the angle between the force of gravity and then this is the force of gravity acting downward, weight acting downward, and displacement of coolie. They are perpendicular to each other. Yes. So thus, what happens here? The angle between the force due to gravity, that is weight of the suitcase, is normal to the displacement of the coolie, which makes angle between them 90 degree. And since cos 90 is 0, hence work done will also come out to be 0. Children, while writing down the reason, you have to explain every part as written in this example. You have to write down why angle is 90, and by putting 90, how answer is coming to be 0 joule. So see, I have explained everything, that what is the direction of force and then what is the direction of displacement. It has been explained. Then only I am writing that the angle is 90 between them, and then putting 90, cos 90 is 0, therefore our answer is coming to be 0. So while writing a reason, make sure you are explaining whole of the concept. So children, now you may take a break of 10-15 minutes and write down the answers of the question which you are able to see on the screen. I have given you 3 questions. Question number 1 is, what is the work done when the body is moving in uniform linear motion? We have done linear motion in class 8th, and I have explained linear motion in exercise 1C also. So what is the work done when the body is moving in a uniform linear motion? Give reason for your answer. Second question is, what is the work done when you hold an object and walk? So when you are holding an object and walking, what type of work done you are doing? And thirdly, what is the work done by the tension in the string of a simple pendulum in one complete oscillation? So what is the work done by the tension in the string of a simple pendulum in one complete oscillation? So children, kindly write down the answers in your physics notebook. Try to write down the reasons, and after you have written, resume this audio video lecture and cross-check your answers. First of all, take out your notebook and start writing the answers by pausing the video. So I hope by now you have written the answers. Now children, your answer number 1. Now the question was the body was moving in uniform linear motion. Whenever a body is in uniform motion and is moving in straight line, linear means straight line motion. So when a body is moving in a uniform motion and is moving in straight line, then its velocity is uniform. Its velocity is constant. And since there is no change in velocity with respect to time, so if there is no change in velocity with change in time, then in such case, acceleration is 0 meter per second square. And children, we know the formula of forces, mass multiplied by acceleration. So now acceleration is 0, which means force is also 0. And in such case, your work done will be again 0 joules. Understand this answer carefully. So children, this is your answer number 1. Now, what is the work done when you hold an object and walk? It is the same case as that of Coolie. He has holding a suitcase on his head and then walking. So, in this case also, work done is 0 joules. And you can explain the same reason which was written in example B, that is the example of Coolie. Coming to the third question, a very important question, students. What is the work done by the tension in the string of a simple pendulum in one complete oscillation? So children, what is the work done by the tension in the string of a simple pendulum in one complete oscillation? We can write down the reason. There can be two reasons here, because it is one complete oscillation and after an oscillation it must have stopped. So we'll say that work done is 0 joules in this case. Why? Children, you have to write both the cases. Both the reasons have to be written. First reason is for one complete oscillation, that means you start from mean to extreme, extreme to mean, and then mean to other extreme, and then return back to mean. That is one complete oscillation, starting from one point and finishing after covering both extremes and then reaching back. This is one complete oscillation. So in one complete oscillation, you have started from mean position, you returned back to mean position. So what is displacement here? Displacement is 0. Why? Because from where you started, if you reach at that point, then the value of displacement is, recall class 8th, we did in class 8th also. The displacement of a body which starts from one point and reaches back the same point, in such case, we take displacement to be 0 meter. And what second reason is, children see, tension in the string, that is force. See, I have drawn a diagram also for your clarity. Tension always acts in an upward direction, while the displacement, when the bob of the pendulum was in extreme position, the displacement is always towards the mean position. Even if you are taking the other mean position, extreme position, then also if you draw a bob, the tension will be in upward direction. Tension will be in upward direction and displacement will be towards the mean position. So children, the angle between displacement and tension is 90 degree. Both are normal to each other. Both are at 90 degree to each other. So the work done by the tension will be also zero because the angle between tension of the string and displacement is 90 degree and cos 90 is 0. So now children, this was all about work. Now let us start with the next topic, that is power. Children, power is defined as rate of doing work and it is a scalar quantity. This whole chapter, work, power, energy, all three things are scalar. Work is scalar, power is also scalar, and we'll study that energy is also scalar. So children, now it is a scalar quantity. Power will be represented as capital P, and children, as we have learned since our lower classes, that is class 8th, I have told you that word rate means divided by time. So power is defined as rate of doing work. So rate of doing work means work divided by time is known as power. So children, if we write down the units of work, work is measured in joules and time is measured in seconds. And children, SI unit of power is watts. You must have heard this unit when you are talking about electric bulbs, that is 50-watt bulb, 50-watt bulb, 100-watt bulb. Okay, so children, electric power, simply power, if I talk about power only, power is actually equal to work done upon time, and the SI unit of work was joules while time is measured in seconds. So if I want to define watt, that is SI unit of power. So 1 watt is equal to what? How to write down 1 watt? 1 watt is equal to 1 joule divided by 1 second. So how to define it? It can be defined as 1 joule, when 1 joule of work is done in 1 second of time, when 1 joule of work is done in 1 second of time, then it is said that 1 watt of power has been consumed. Or you can simply say, if 1 joule of work is done in 1 second, the power spent is said to be 1 watt. Then children, there are many units which you have to learn. Kilowatt, megawatt, gigawatt. Kilo means 1000. Mega means 1000 multiplied by 1000. Giga means 1000 multiplied by 1000 multiplied by 1000. So if we write down in power form, what I was saying, look students, I am saying that 1 kilowatt is actually equal to 1000 watts. This is clear to all. Then we are having one more term, 1 mega, capital M. 1 megawatt is equal to 1 kilowatt multiplied by 1 kilowatt. That means 1000 watt multiplied by 1000 watt. That is mega. And then comes giga, 1 gigawatt. What we are doing here, 1 kilowatt multiplied by 1 kilowatt multiplied by 1 kilowatt. So if you just see, this is 1000 watt multiplied by 1000 watt, again multiply by 1000 watt. So instead of remembering this, it's better if we write down in terms of power. So look here and write down the powers yourself. What should be the power coming here? Count the numbers of zeros in everything and then write it in terms of power. So in the first part, your power will be 10 raised to power 3, isn't it? The power will come 10 raised to power 3 because there are only 3 zeros. Here there are 6 zeros, so I'll write down 10 raised to power 6. And here, count the number of zeros, there are 9 zeros. So I can simply say that 1 kilowatt is 10 raised to power 3 watt. 1 megawatt is equal to 10 raised to power 6 watts. 1 gigawatt is equal to 10 raised to power 9 watts. Students, there is one more power, unit of power, that is horsepower. If you see the power of a battery or an inverter also, if you just see, it is written in horsepower, and one horsepower, it is written as HP, small h, or you can write down capital H also. Don't, it's better if you write down it small h. So horsepower, 1 horsepower is 746 watts. 746 watts is horsepower. So I hope this is clear to all. So children, here this all conversions you all have to learn, since it will be used in numericals also. So similarly, you can see smaller units also, 1 milliwatt and microwatt. Milli means 10 raised to power minus 3, 1 by 1000. And microwatt means 10 raised to power minus 6 watts. So children, milliwatt and microwatt are smaller units of power, while kilo, mega and giga watts were bigger units of power. And then we are having one more unit of power, which is used in mechanical engineering, and it is related as like this. You can write down horsepower like this: 1 capital H dot capital P dot, and its value is 746 watts. Children, the power of an engine is usually measured in horsepower or kilowatt. And there is one more formula of power. One is work upon time, which we did earlier today. And there is one more formula, that is force multiplied by velocity. This is also power. And it is also derived from the same formula. Children, we did power was equal to force divided by time. So if I write down force, it is work upon time. What was power? Work upon time. And we know work can be written as force into displacement upon time. So displacement of upon time is velocity. So therefore power can be written as force into velocity also. Rather, it will be also good if we write down F cos theta. But for our syllabus, we'll be using only F into V, force into velocity. Both are correct formulas for our case. Now children, power spent by a source depends on two factors. What are they? One is work and the other is time. So power is directly proportional to work while it is inversely related to time. Why? Because power is in numerator while time is in denominator on the right side. So power and time are inversely proportional. It means that less is the time taken to do a work, more is the power of that source. Now children, there is a very important concept coming along. Work is independent of time. Work does not depend upon time. Thus, if two students are given an assignment to complete, and one of the students complete the assignment in 2 hours, while the other student is completing the same assignment in 6 hours, then work done by both students is same. It's not different because they are doing same work. They are completing the same assignment. So the work done is same since work does not depend on time. But the first student has done it in less time. That means his power was more as compared to the student who has done the work in 6 hours. Why so? Because power is inversely proportional to time. So students, kindly pause your video and audio and go through the topic of power carefully.